Okay, welcome back to Lecture 5. This is a short segment just covering a couple other additional features that are available as part of the EC2 service. One of those features is the EC2 placement groups feature. So generally when you're launching EC2 instances, those EC2 instances are being created as virtual machines on physical servers within data centers. And these EC2 instances can be sort of spread a certain distance apart from one another. They can be sort of randomly distributed across multiple data centers within a particular availability zone, maybe even across multiple availability zones within a region. And even though the network latency and the network performance between these various EC2 instances is generally pretty good, oftentimes it can be single digit millisecond sort of latency. There are certain use cases where you want to ensure that you have the fastest possible network performance. Uh, the fastest possible network connecting your EC2 instances together. You can think of use cases like setting up a Hadoop cluster, or if you've got a database and you have kind of like you've got sharded database instances. There are just a whole class of use cases where you want to ensure very, very low network latency between your computing nodes, and you want to ensure that you have extremely fast network performance. Maybe you need to ship large amounts of data between the computing instances and some sort of like cluster that you have set up. Well, a placement group allows you to place a group of EC2 instances close together, basically. So it allows you to sort of geographically ensure that these EC2 instances are located as close as possible together. And these instances are going to be connected via a very low latency 10 gigabit per second network uh, sort of network infrastructure. Now, you can't launch any sort of EC2 instance inside of a placement group. For example, you can't put T2 micro instances in a placement group. There are only certain types of instances that are allowed within these placement groups, and these are generally your more IO optimized, CPU optimized, database optimized type instances. And one of the key things to note is that you have to define the placement group before you start launching EC2 instances into it. You can't just take existing EC2 instances you've created and then put them into a placement group. You have to create the placement group first, and then when you're launching the EC2 instances, you specify that you want those instances to be in that placement group. And if you have multiple placement groups, you can't merge them together either. So that's one thing to note. As you can probably imagine, the placement groups increase the cost of your EC2 services. There's an increased cost associated with being able to specify that these instances are located close together and that they are all tied together via a very high performance, low latency uh, uh, network architecture. Okay, the next service I want to talk about is the Elastic File System Service, EFS service. And the Elastic File System Service allows you to share files across multiple EC2 instances. Now, you might be thinking to yourself, uh, haven't we already talked about a couple other ways to store data and store files in EC2? And we have. There's actually three different services that allow you to store data, but they all store data in a different way, and they all have a different sort of purpose. We talked about S3, the simple storage service, and that's an object storage based service where we're storing data in buckets. Essentially, we're storing individual files. The files are the key, the value, the data in the files is the value. We talked about the EBS service, the Elastic Block service. This is a block storage service. It's like a storage area network. And an elastic block storage allows you to create data volumes. These volumes are attached to our EC2 instances. And the EC2 instance and the operating system on the EC2 instance sees the volume like it's a hard drive, basically. And we can install operating systems, we can install our applications and file systems on EBS volumes. And then finally, we have the Elastic File System service. And the Elastic File System service is like network attached storage or like a NAS device. This is a device which presents a network file system, a network directory, a network folder that is attached to our server. And so it's not like a hard drive, it's like a network folder that we can store data on. And the benefit of EFS is that it's a fully managed file system service. So we don't have to really figure out how to configure it, or we can just simply deploy it. And it allows us to create this shared file directory or file mount that we can attach to our EC2 instances. We can share the same file directory across literally thousands of EC2 instances, and we can scale the amount of data that we're storing in this file mount to literally to petabytes of data. It works with both Windows systems and it works on Linux systems, and it's actually based on a really standard uh, protocol called NFS, or the Network File System Protocol version 4. NFS has been in use for decades in the Unix and Linux world, and so this is a very common way to create file mounts on servers. All the files that we store on EFS are also then redundantly stored across multiple availability zones, giving us increased durability of that data. So, um, so why would you use EFS? What are some of the use cases? Well, you might use EFS to create a content repository. So like you might have customers who are uploading files to your website. You want those files to be accessible from every one of your web servers because you've got a fleet of web servers that you're distributing requests across using an Elastic Load Balancer. And you want all of your web servers to be able to access all the files in the content repository. Well, you could mount an EFS directory and attach it to all of the web servers and store all of your files in this shared directory. You could share user home directories across instances using EFS. That's a pretty common scenario in something like a campus computer lab, where students need to access their home directory, and they need to be able to access their home directory on any workstation in the computer lab. Well, why would you use EFS versus S3 versus EBS? Well, EBS is like a hard drive. So EBS allows you to like literally install an operating system and run it off of your hard drive, right? Or off of your EBS volume. You can't do that with the Elastic File System. The Elastic File System isn't going to act like a hard drive or a disk partition. It's acting like a shared file directory, a network accessible file directory. Well, what about S3? Why would you use something like EFS versus S3? You can you can store files in either one. Well, there it if you're working with an older application, with a legacy application, it's likely that that application wasn't designed with S3 in mind. Legacy applications don't know how to talk to S3 properly, how to upload and download files from an S3 bucket. Whereas most any legacy application will be able to work properly with EFS because the legacy application, it sees EFS as like any other directory on the file system. So there's no, there's less of a compatibility issue. So what I tend to see is that modern applications that are designed for the cloud are generally designed to work with something like S3, whereas our older applications are designed to work with file systems, and in those cases, a solution like EFS can oftentimes provide us with a better solution.